Now, we have an invited speaker here, Mr. Hsuan-Chih Leo. So he is currently an associate researcher at Intelligent Transportation Systems Center, China Engineering Consultants, Inc. And he has the practical experience in intelligent transportation systems, and he conducted a project in Taiwan when he was in National Cheng Kung University. So we have the honor to invite him here and see the recent project and developments in ITS in Taiwan. So let's applause. Welcome.
Okay, thanks for the Dr. Chen's invitation. And my name is Hsuan-Chih Wang, Wang Xuan-Chih in Chinese name, and you can call me Leo if you find difficulty in pronouncing it. So today I'm going to share my practical experience in traffic signal control systems in Taiwan. And as Dr. Chen mentioned, I'm currently an associate researcher at Intelligent Transportation System Center at China Engineering Consultants. So let's briefly introduce about me. When I was an undergraduate student, I majored in transportation and communication management science. And after obtaining my bachelor's degree, I continued master's degree in also National Cheng Kung University. And prior to joining the China Engineering Consultant in Taipei, I was a traffic engineer at the Research Center for Smart City and Transportation Network Service in NCKU. So today's presentation will be separated into two parts, and this part will be, I will introduce the 都市交通控制协定. The English name is Urban Traffic Control Communication Protocol, UTCCP version 3.0. And in the next class, I will describe my personal experience in practical traffic control system. So this part might be a little bit boring, so just I will make it quickly through it and make it interesting as possible. Okay, this is my outline. And first I will make a brief introduction to what is UTCCP and how it can be used. And I will introduce the Taiwan Traffic Signal Controller. I know that in this lecture, Dr. Chen has introduced the traffic controller system in American, but in Taiwan, that is a huge difference. So I will introduce that. And I will introduce how the UTCCP work in a real-world project, and I will mention the future development of the UTCCP. Okay, let's start with the introduction. So, what is UTCCP? UTCCP mainly is a standard format of messages that in order to achieve interoperability and interchangeability among different traffic control devices, especially from different manufacturers. So you can just try to imagine the scenario that UTCCP does not exist. Let's say if you were a traffic engineer and you would like to update the signal timing plans, and if there is no UTCCP, the manufacturer A of the traffic controller, you may need to use command A to achieve this goal, and you may need to use command B and then command C for different manufacturers. So that is a huge problem because it is a laborious task and it is challenging for traffic engineer. So UTCCP is simply a uniform language for the traffic control devices in various manufacturers. Okay, this is a history of UTCCP. And the first version of UTCCP was published in 1988 as titled Computer-Based Traffic Signal Control System Communication Protocol. And now we here to introduce is version 3, which is published in 2005. And the title changes the Urban Traffic Control Communication Protocol. So the change was due to 2 reasons. The reason one is contemporary traffic control systems are all based on computer systems, so we simply need not to additionally specify it is a computer-based or not. So another reason is, in addition to signal control, other traffic control related systems such as vehicle detector, changeable message sign are also included in this protocol and in our urban traffic control system. So this is why the title was changed. Okay, this is the structure of this UTCP handbook. So the most important part is the message set. It regulates 3 types of traffic control devices. And the first is the generic message set that can be applied to all the traffic control devices. And this is a traffic controller specific message set. And this is vehicle detector and the changeable message sign. Today, we will put our focus on traffic controller message set. Okay, this is what you will see in UTCCP. I try to translate the Chinese into English of the main part. So you can see here's the title of this message set, which, for example, is a generic message set, and it will define the message ID, the type, and the purpose of this message, and the message level, and the description of how this message is used, and the format of this message. Okay, the coverage of UTCP, just as I mentioned earlier, there are 3 types of traffic control devices are included. The first is traffic signal controller, and the second is vehicle detector, and the third one is changeable message sign. Okay, there are 3 levels of this message set. The first one is a basic, and the second one is advanced, and the third one is option. And there are 4 types of it. The first one is setting. The setting is used to sending a setting command from X to the traffic control devices. The X may be the traffic control center or roadside unit, external computers that connected to the traffic control device. So you can use setting commands to set your command to this control device if you want to update signal timings, update the settings. And this is the second one, request. You can send a request from X to the traffic control device, and also you can it will respond your request, or it may actively respond without being requested, such as the signal timing may keep periodically updating their steps, just like currently it's a green light phase, and we have remaining time 20 seconds, and it will periodically active response. Okay, I will quickly go through it, all the message set. So you will see this is a generic message set, and these are applied to all control devices. So, such as response process, and you might see the reactivation of the equipment or the ID management. So you can use a setting command to reactivate the traffic control device, and also it will respond whether the status of this command is correct, is successful or not. And this is ID management, so you can also request it and it will respond you. Okay, the third one is report for the power off, because if the traffic control device is powered off, is a significant problem, so it will actively respond it. The Chinese here is an actively response. And this is a reactivation and task. And also you can set up the time of this equipment. Okay, those are the generic message set. And this part is the traffic controller message set. And you can see what you can do to the traffic controller include current control strategy management. So you can set current control strategy. Control strategy includes TOT control, time of day, fixed time, or we call it fixed time control, or adaptive control, actuated control. So you can set the mode of this controller. And also you can set a reversible lane parameter settings. The reversible lane is also controlled by the traffic signal controller. So if you look up the UTCCP, you might find there are two sections that are pretty similar, and you might have a question that is this duplicated? No. If you look up the detail, you will find that these two sections, the difference in these two sections is used for setting up weekday plans, and this is used for setting up special days. Weekdays just like Monday, Tuesday, and a special day just like the weekend, the Dragon Festival day, or some days like that. Okay, and you also can set up the signal phase setting, and you also can set a detailed parameters of these signal timing plans. Okay, and you can manage the signal timing plans and also setting them and the weekday signal time management. Also special day segment time management, you can define what day is a special day and what day is not a special day. And you can also set in a signal timing plan and a signal timing management. Okay, and if your controller is support the actuated signal control, you can also set the detailed parameters of this actuated control. And also, you can make a schedule on the actuated control. For example, maybe your actuated system is only activated during the peak hours and return to the TOT control during the off-peak hours. Okay, this is a special day, the actuated control management on special days. And this is this part is most important in UTCCP because it regulates how the phase step control can be done. And this one I will go into the detail in the next class, because if you want to perform transit signal priority, you need to frequently use this command to achieve your goal. Okay, this is a vehicle detector data spot. I will not go through all of them because this is not our today's main point. So I will just show you it. The format of this command are really similar, and it serves like the dictionary. So whenever you need it, so you can find out the detail in this handbook. Okay, then this is a changeable message sign. So, okay, this is the most boring part, so we just go through them. So now I will introduce Taiwan traffic signal controller. So you may have learned about the American system just like this. It's typically we so-called a lane-based system, which means each lane has a traffic light that you can follow. But in Taiwan, you will see there's two lines, but there's only one traffic light on it. So we call it as a direction-based. So this difference will result in the fundamentally structure of the traffic controller design. Okay, so this is the traffic controller in Taiwan. So you will see there are several parts of it. First, this is the a switch, several switches. So you can manually use this switch to determine the mode of this controller. For example, this word might be a little bit smaller. And this Chinese is mean manual control, and this is automatic control. So this switch is off. So this controller mode now is automatic working, and if you switch up, then it will be manually controlled. So there are other switches that you can use. Typically, this is what you see the police officer, they open the cabinet and they control the traffic light. Is how they is typically are doing some setting in this controller. Okay, and this is a screen that will show how the traffic signal is currently running, and this is the signals that it serves as the preview system that you need not to look up to see how the traffic light is now correctly working. You can simply watch it, so it will tell you how now currently the traffic light is working. And this is a port that send command to our traffic light system. Okay, so if you open the cabinet, so you will see the UTCCP regulates how we can communicate with traffic controllers. So how it works is, in this image, you can see there's a roadside unit. You can imagine it is just like a personal computer. So you can code some program, write some program in it. And if you follow the UTCCP format, you can send a command message to the controller through this RS-232 port. So there is a line connected to the controller, so you can easily to retrieve the signal timing setting, or you can send some command to it. Okay, let me introduce some terms in Taiwan controller that might be different from US system. So the first is the control strategy. The control strategy defines how the controller is the strategy that the controller is currently using. For example, there are 8 types of control strategy, but I will introduce 3 of the most important control strategy that we use in real-world project. The first is peak time control, or we call it the time of day TOD control. It will operate the signal timing that is stored in the traffic controller. And the second is manual control. If you switch on this switch, then the controller will show this controller currently is running the manual control strategy. And the third one is adaptive control. Adaptive control is when you want to implement an active transit signal priority or emergency vehicle signal preemption, then you will use this control strategy. And this is the screen of the controller. It will show several information. The first one is the phase, currently is running which phase, and the step, and the remaining time, and the date, and the different time. And the step, the phase and the step, I will explain it because it is not in the US system. The phase, the definition of phase is different from US system, and the step is only used in Taiwan controller. So for example, in this controller, now it is running a fixed time control. you can see a fixed time control. It has a notation on it to indicate that it is running fixed time control. Okay, the next is step. Step in Chinese we call it 步阶, and there are 5 steps in Taiwan's controller. The step 1 is green, and the second one is pedestrian green. You will see this green person is running, so this is the second step. And the third step is a pedestrian red. You will see a person that is red and standing, and this is step 3. And this is step 4, and step 5 is yellow and all red. Okay, in Taiwan's system, we not only have a space, we also have a subphase. So a phase, the definition is that a phase should consist all of 5 steps, which means all these 5 steps should exist, and also their values should not be 0. However, in subphase, might consist of 5 steps, which means that some of the steps, the values of these steps might be 0. For example, you might skip pedestrian green or pedestrian red if you set these 2 steps as 0. So you will, for example, you will run a 10 seconds of the green, and you set these 2 as 0, it will switch directly to the yellow and all red. It is implemented in when in Taiwan's intersection there's no not all the intersections have the pedestrian green or pedestrian red, right? So this is how the subphase is designed. Okay, and this is a phase order. The phase order indicates the type of the phase. For example, you might have a simple 2 phases, and you might have a leading phase or the lagging phase, and they are ordered in a unique order. Like the simple 2 phases are 0, 0, and leading phase is 1, 0, and the lagging phase is 1, 1, such that. And there are, I think, about 40 types of phase orders in Taiwan commonly used. And then the max green and min green is the same as the US system. Okay, so we will introduce how it works, how we use this UTCCP in our real-world project. Okay, I will give the 2 examples. First, if you are a traffic engineer, you would like to know the content of the signal setting of that controller. How can you do that, and how can you know that? For example, in order to perform the real-time signal control application, such as active transit signal priority or emergency signal vehicle preemption or adaptive signal control, the system usually needs to know the content of the signal setting. Otherwise, if you don't know the current setting of this traffic signal controller, you will not be able to perform your algorithm to optimize the signal settings. So there are 2 types of the setting that we typically need to know. The first is the current status. It defines the subphase that the controller now is currently running, and the step of the currently running step and the remaining time. And the second one is the complete plan information. It defines the what kind of plan is currently running, and the phase order, the cycle of it, the offset, the green, min green, max green, yellow, or red, or pedestrian green, or pedestrian red, something like that. And after knowing all this information, so you can perform your algorithm to optimize the signal settings, and then you would like to send your new signal setting to a controller. For example, if you are you are doing the transit signal priority, you detect the bus is approaching and you perform your algorithm and say, oh, now I need to extend my green time to, for example, 30 seconds, and currently it's 20 seconds, the remaining time is 20 seconds, and I would like to add 10 seconds to my green time. So you need to send a new signal setting command to the controller. So you can use the message set that I mentioned earlier to achieve this goal. Okay, so if you would like to get the current content of the specific plan or phases, you can use these 4 types of commands. The first is 5F4C. 5F4C is used for query about current phase step and remaining time. And 48 are used to know the properties of the current signal plan. And 44 is used to know the detailed parameters of a specific signal plan. And the last one is used for know the properties of a specific signal plan. And these 2 are similar, and you can see these 2 is similar, and the most difference is this is used to query about the current signal plan, but this is used to query about a specific signal plan. It may not be running currently, but is stored in the traffic controller. Okay, so if you look at detail about this command, it will tell you this, like 5F4C is used to query about current space and step. And it will remind you that this command is only applicable when control strategy is adaptive control. So if you would like to use this command, you need to set the control strategy first to set it as adaptive control first. And then it will define how the message is processed. For example, you first send the message, and the traffic controller will receive the message and report the message in 5FCC. It will this 5FCC defines how the current step and remaining time is reported. Okay, let's take a look at 5FCC. You can say this is a message format, and this is the content of the message. For example, here it defines it will report current control strategy and the subphase ID and the remaining seconds. Also the step ID. I forget to write it down. Okay, so this is the define of these parameters. Such as here you can see subphase ID and step ID is the same as in 5F1C, and the control strategy is defined in 5F10. Also, it will tell you how this message is processed. Okay, the second one is I would like to query about the property of current signal plan. And this will also respond the message in a specific format. So if you receive the message, you need to look into this format so you can correctly process it. Okay, this is the format of our message set. It will define the plan ID, the direct, the phase order, subphase count, and cycle time and the offset. Okay, and you can see the parameter, the definition of the parameters, and can refer to this message, and also it will tell you how the message is processed. So you can see the whole process is similar. You just find out what you would like to do. Just look up like a dictionary and follow the steps, the instructions of this description, that you can correctly get the information you want, or send a command that you would like to the train controller to perform. So they are all similar. Okay, this is the plan ID. Then you will see the definition. I just adopted from this command. The plan ID can be separated into 4 parts. And if the plan ID is 0, it means it is now currently a dynamic plan. So all the parameters may be changed, and they are all dynamic. There's no specific time for like green, the pedestrian green, the yellow, or the all red. And 1 to 50 is the TOD plan. So you can store as many as 40 specific plan in the controller, and 47 and 48 are used for specific purpose. For example, 47 is used for real processing actuated, and 48 is used for a default plan when the controller is unstable or there's something bug in it, so it will automatically transform to the default plan. And this is the direction of the phase. So you can see it might have a north, east, north, or east, something like that. But this is a tricky part that I will describe it in the next class. So you can keep this in mind, because you see there's a debate definition, right? But in reality, no controller manufacturer has implemented it. They all fill this value into 0, and this resulted in a big problem. So I will describe it in the next class. Okay, this is if you would like to know the content and detail parameter of a specific plan. So you can, just like if you have experience in coding, in writing a program, it's like a function that you have input parameters. So you can put the parameters in this function, and it will respond to the content that you would like to know. Okay, this is a similar process, and also this one is similar, and it will report the content of the current signal plan. Okay, so I will just go through it. Okay, this is the definition of the terms that I mentioned earlier. So if you are not familiar with this term, you also can find a definition in the UTCCP. Okay, and this is used to query about properties of a specific signal plan. Okay, and this will report the properties of the specific signal plan, and this is a response to this message. You can see there's rules. It's a rules, and just like this is a 5F45, right? And the response, this is a command message, and the response will be 5FC5. So it typically changes this first number into a C. So there's a rule. Okay, so that is the 4 messages that we used to know. We're using them to know the content of the signal settings. And now, if we would like to send a message, how we can do that? We typically use 2 types of message. The first is 5F10, and it will set the control schedule of the signal controller, and you can set it to adaptive control length. You can adjust the time length of specific step of a subphase. Okay, this is the details. First is to set the control strategy, and you can set the control strategy that you would like to do the control strategy there are 8 control strategies, just like I mentioned earlier. So, for example, if you currently is running TLD control, it's bit 0, and you would like to change it into adaptive control, so you can set it as a bit 4, and you can specify the time length of the chosen strategy. For example, adaptive control might not be used for the all day long. It might only be used during the peak hours. So you would not, you would like to set the effect time. So after the effect time, it will return back to the TLD control. So you need not to periodically to monitor the status and so on to know that, oh, this is now currently it's off peak hours, so I need to send a new command to ask the controller to return back to the TLD control. You need not to do that. Okay, and this is 5.1c, and it is used to subphase to set the step ID, the time length of this step of a subphase, and this effect time refers to the time length of a specific step of the specific subphase. And this is an important part. So just as I mentioned, if you would like to extend the green time to 30 seconds from the original one is 20 seconds, and you would like to extend to 30 seconds, so you need to use this message set. However, there is a big problem in this message set because the effect time here, the definition of this effect time is unclear, and it results in a big problem because various manufacturers has different explanations on it. So it is very hard for you to implement the traffic control system. Okay, so this is the definition of the effect time. And typically, if you set all the parameters as 0, then the controller will switch to the next step immediately. So like if you send the command with all parameters with 0, and currently it's a pedestrian green, and it will switch to pedestrian red immediately. Okay. Okay, so this is the whole process of the communication. For example, the example one is we would like to get the content of the current specific signal plan or phase. So you write a program in your roadside unit, a little computer, and it will send a command message to the traffic controller. We say you would like to know the content of the signal settings. You need to change the control strategy to adaptive control first. So if the message is successfully executed, then the controller will send an ACK. ACK is just like a successful message that the controller tells you, hey, that I have received your message and I have done what you would like to do. And then you can send the query message to know the signal setting that you would like to know. Okay, and this is example 2. And sorry, I forgot to change the title here. So first, you also need to change the control strategy to adaptive control, and then you can send this command to adjust the time length of a specific step or of a subphase. Okay. Okay, this is a future development. So you might come up with an idea that, as I mentioned in the first UTCCP, UTCCP version 3.5 has been published for more than 15 years. And there is no official update until now. So this handbook, we have used it for more than 15 years without any update. So you might wonder, there will be huge progress because 15 years ago, there's no cell phone, there's no smartphone, there's only 3G, even no 4G. So it is a big problem. So during these 15 years, facing new technologies such as CAV, V2X, Taiwan, related traffic control applications, many traffic control device manufacturers additionally added some custom design protocols to meet local city government needs. And these protocols may work fine within the city, but when it comes to intercity traffic control, such as regional traffic management, they will encounter a huge problem of interoperability and interchangeability, since none of these new added protocols are included in the official UTCCP. So the problem in the first page will occur again. So, sorry. Fortunately, the Ministry of Transportation and Communication, MOTC, knew this problem and has launched a series of forums and workshops to make an in-depth analysis in revising the UTCCP. So the new version of UTCCP is expected to be officially published in 2023. Okay, this is a part 1 lecture, so if you have any questions, are welcome. Okay.
Is this protocol only used in Taiwan? And the second question is, you mentioned we use 8-bit to represent 8 control mode. And does it mean we will enable 2 modes at the same time?
Okay, so you have 2 questions. The second one is if we can set up 2 control strategy at the same time.
Yeah.
Yeah. You can send this kind of command in the controller. However, the controller has a priority on this control strategy. For example, if you simultaneously send I would like to turn on adaptive control and manual control. If you send a message like this, the priority in the traffic controller is the manual control is larger than the adaptive control. So this priority is bigger than this. So the manual control will just override it. So the result will only execute 1 control strategy. So you will not see the several control strategies are operated at the same time. They have a priority rules in it. And sorry for the first question is.
Is this protocol used in Taiwan?
Yes, we are using it in Taiwan. Currently are using. And in the next class, I will introduce my practical experience on designing traffic control system, and we frequently use this message set. So I will make an in-depth analysis on it.
So there's no other countries.
As I know, this UTCCP is only applicable in Taiwan, because as I know, the Taiwan traffic signal control system is extended from Japan. So if you ever travel to Japan, you will see the signals is just like in Taiwan, right? So as I know, this system is unique in Taiwan. So it's not applicable to other countries.
Is there any protocol used globally? For example, international organization publication?
Yes. I don't know if Dr. Chen has mentioned it. For example, in US, they have the same system. They have what we call US version, UTCCP, and in my experience, they are the same in Europe, but I'm not sure. So yes, because Europe traffic signal systems in Europe is similar in US. So I guess they have shared some common properties and common control rules, but in Taiwan, this is a different story. Yes, so this is due to a fundamentally difference. Just like I mentioned, we are direction-based system and they are lane-based systems. So this fundamentally difference will result in a completely different system. Okay, so any questions? I'm told that there will be a break, 10-minute break, right? Okay, so we'll just stop here. Okay.
So we'll take a 10 minutes break and be back at 11:10 for the next session.